Hello and welcome everybody. My name is Süleyman Gemici and I have been working for Valmet Corporation more than 10 years. And thank you very much for the opportunity given by the conference and joining here and sharing our study with you. And today I'm going to speak about the new tools to optimize sludge dewatering while, in wastewater treatment plants, which is important, I believe. And as Valmet, we have developed a concept, automation, a control concept to enable water treatment plants to optimize their sludge dewatering processes, and based on real-time online TSS, total suspended solid measurements devices. And before starting, just a few words about the company. Valmet is a technology service, product and service provider for actually decades in especially pulp and paper and energy industries. With more than 12,000 professionals around the world, it is doing this job successfully. With the sales in 2016, net sales 2.9 billion euro, it's continuing its operations from its headquarters in Espoo, Helsinki, and maybe better to mention that it is also a listed company in Helsinki, Nasdaq Helsinki stock exchange. I'm going to speak about the Valmet SDO, which stands for Sludge Dewatering Optimizer Package. This is a concept, this is a control package, full package, for automating the centrifuges and any equipment which are used for dewatering and to produce dry cake. In Valmet, this was done by automation business line. It is actually one of the major departments in the company, and with 1,600 personnel all over the world. And main focus services and products delivered are pulp and paper, wastewater, other process industries, power generation, and of course, we also need to add marine industries. It's very well-known brand in pulp and paper industry automation market. Today, I'm going to speak about the SDO through a real case, which was done in one of the big, largest wastewater treatment plant in Finland, Tampere-Vinikanlahti wastewater plant. In this wastewater plant actually treats municipal and industrial wastewater about 70,000-80,000 cubic meter in every day, which produce 25,000 cubic meter sludge annually. The water sludge is used in agriculture, landscaping, road bank covering, and landfill sites. It has mechanical, biological, and chemical treatment processes in the plant. Biogas produced of the two digester is used for energizing the plant itself. The problem actually came when the customer wants to have a fully automated system in their sludge dewatering process. It is very well known that the most critical issue in doing that kind of control is having a reliable and accurate TSS measurement should be online. But almost every wastewater plant just follow TSS values with some optical online devices and also mainly based on the laboratory samplings. Laboratory samples are not good enough, frequent enough. Quality control of centered water based on infrequently taken lab samples is not adequate. In this graph on the left top, the green spots are indicating the measures taken by the devices, TSS online devices, while the yellow spots are just those laboratory samples. In the right bottom graph, you see that the one-day data actually depicting only 1 or 2, 3 times laboratory samples give us the data about the measures of TSS, which is not enough because lab samples represent centered quality at that specific moment. After a half an hour, the situation can be totally different. Therefore, you must have to monitor this parameter continuously. In this SDU package, applied the process as shown in the graph. There are Valmet TS, we call TS, total solid device, before and after thickening, and before drying and after drying, and also on to the centered water. And above this, there is an HMI, human machine interface, to enable the operators to monitor the process values and to control them. The project started in 2015, and Valmet SDO, together with the TSLS and DS measurement devices, ordered by the customer, and then just for one of their centrifuge, because it was clear that they wanted, and everybody wanted to make sure that it works properly. In the same time, the plant wanted to optimize also primary sludge pumping, as well the sludge feed to the digester based on solid measurements. At the centrifuge end, customer wanted specifically to minimize centered solid amount, and also the dry cake solid amount should be in the optimized level in order to minimize the transporting costs. Also, polymer selection and optimizing of the polymer usage was one of the goals. And then project was completed in January 16. And what Valmet SDO is actually, it is consisting of hardware and software elements. In this centrifuge application, of course, centrifuge itself to remove solids from the water by way of centrifugal force. So the dry cake target value varies, but usually cake solid is in the 12 to 35% range. It is important that the dry cake solid amount as high as possible in order to transport costs minimum and incineration costs are minimum level. Reject water or centered solids amount needs to be minimized in order to the material is not recirculating inside the plant and cause capacity losses as well as polymer and dewatering costs. The centrifuge controllable variables in this case are torque of centrifuge, polymer dosing. Centrifuge-dependent items are max flow, sludge consistency, and volumetric flow to the centrifuge. So, there I said the equipment, hardware parts consist of 3 different brands of TSS measurement. And these are Valmet TS, which is measures 0 to 40% TS value, Valmet LS. It is working between 0 to 0.5%, which is 0 to 5,000 ppm, let's say, on centered water. And DS is for open measures, about 15 to 35%. We should mention that this device is based on microwave technology. It's nothing that it makes it more stronger. And then after the application of the process, it was proven after 1 year that the measurements are very correct and reliably working without maintenance. So, and this graph showing 2 months values between the data taken by the measures by the devices and the laboratories. You see the correlation, how correct it is. At the end of the project, 1 year after the project started, the customer reached the values, savings, as shown on the slide. These are coming from the sludge pumping from clarifiers, reduced from 60 cubic meter to 50 cubic meter an hour, which is by reduced excess water to thickening. Energy savings are approximately 37%, generated 5,000 euro annually. And the second savings from digester solids increased from earlier 3.5 to 5%, led 32 less sludge to treatment, increased biogas production, and then solid content of centered water is now 50% lower than before and stable. Polymer consumption has decreased almost 40% from level 8 kilogram per ton to almost less than 5 kilogram per ton, and saving with less material circulated created 10,000 euro annually, and polymer saving itself 49,000 euro annually. And then dried cake solids actually content has increased by about 1.3%, which is improved dry cake dryness from 29% to 31%, which led us to create savings in transportation cost approximately 80,000 euro in every year, so in the first year. These values have been calculated mutually with the end user and then proven, verified by them. So after 1 year operation, the system generated 140,000 euro savings in only one centrifuge. Thank you very much for your attention. And I would like to add that we have some data regarding of it in the USB sticks just beside the water and at the entry. Thank you.
Now we will change our topics to another important component of energy efficiency tools. Now we will talk about benchmark. Benchmark is an important tools, maybe not for energy, for everything, for managing or for improve any plan or any process or any strategical plans or process in water and wastewater sector. So now we will introduce and welcome our speaker, Mr. Iyad Zreiqat. Mr. Iyad Zreiqat have a master's degree in water resources and environmental management. Now he was a student in Berlin Technology University. He will show us a case study from Jordan about benchmarking wastewater to improve efficiency. So welcome, Mr. Iyad.
Okay. Thanks, Engineer Yasser, for introducing me. Today, I would like to present an important topic, actually, for in the Jordanian context. Okay. So today, I would like to present the energy benchmark for the wastewater treatment plants in the MENA region, taking Jordan as a case study. Basically, yesterday I heard that we went 2 ranks lower in the water scarce scale, from the 4th water scarce country in the world to the 2nd water scarce country in the world in one of the presentation. Since 2008, the Ministry of Water and Irrigation actually has considered treated wastewater as a non-conventional water resource for agricultural purposes. And this effluent stand, or this treated effluent, should actually comply with the Jordanian standard 893/2006 in order to be reused. And to reach this, these standards, we need to consume a lot of energy to use so much energy in our wastewater treatment plants to achieve these standards. For that reason, I think this topic would be very interesting beside the Jordanian standard to have also a benchmark for Jordan. So in my presentation, I'll go through why do we need energy benchmark, why energy saving is important in our wastewater treatment plants. I will also have an overview on the wastewater treatment plants in Jordan, and presenting after that some key figures regarding the potential energy benchmark for Jordan. And I will also go further in the optimization process to one case study, Aqaba wastewater treatment plants as energy auditing and energy analysis. And I will speak, if I have the time, on a little bit on introducing one of the tools for modeling to use it for potential scenarios, as to test different scenarios for optimization. Actually, our challenge is to have effluent quality meets the Jordanian standard, but with lower energy usage. However, we need more energy also if we need to purify the wastewater further, by implementing also nitrification and nitrification process. But why do we need to actually optimize our wastewater treatment plants in terms of energy consumption? The reason are that our fossil fuels, our fossil resources are limited, the increase of energy prices, the climate change increasing CO2 emissions, and the last but not least is reducing our operational costs of the wastewater treatment plants. So let's have an overview on the wastewater treatment plants in Jordan. We have around 31 wastewater treatment plants in Jordan. Around 50% of these wastewater treatment plants actually apply activated sludge system. And the activated sludge system is the most energy-intensive process within the wastewater treatment processes. Actually, I have done the first preliminary study in 2014. I collected some data, but I consider my study 20 wastewater treatment plants, because in 2014, some of the wastewater treatment plants were closed or were newly built, or some of them are stabilization bond, which I excluded also from the study because they have very marginal energy consumption, a very low energy consumption. So the next slides will be talking about the 20 wastewater treatment plants. Let's have a look. This is the total electricity consumption of wastewater treatment plants for the 20 wastewater treatment plants, 95 gigawatt hour in total, and with a total electricity consumption cost of 8 million Jordanian dinar. And we see that on the pie chart shows the 77% of the energy consumption actually in the middle province. So this is the highest usage within the provinces. And as I'm focusing on activated sludge treatment processes, I have this scheme for activated sludge process, which actually shows the component for energy production, and also shows the biological treatment as the highest energy consumption within the treatment units. If we look more clearly, we look at the pie chart, which shows that the biological stage takes around 66% of the whole treatment processes of activated sludge. Treatment plants in Jordan actually follow the Jordanian standard 893, 2006, and most of the wastewater plants should comply with discharge to water bodies and valleys. However, we don't know how much energy are we using in our wastewater treatment plants. Are we using much energy? Are we using low energy? That's what we don't know. For that reason, it's important to have, beside the Jordanian standard, also the energy benchmark. So let's look at the potential energy benchmark for Jordan. Actually, optimization process, energy benchmark is a part of the optimization process. So we have we have done our study based on the worksheet from DWA 216, which is an instrument for energy optimization of wastewater plants by applying or conducting energy check and energy analysis. And this actually published in 2015. And the same year, we have also guidelines for the MENA region, also as energy efficiency in water and wastewater utilities. And based on these worksheets, we designed a questionnaire and distributed and sent it off to the wastewater treatment plants to collect some basic information and the information related to the energy consumption. And then we did an energy assessment for the data based on, we calculated the population equivalent based on the, that each population equivalent is like around 100